So we'll now closely examine the structural classification of joints, starting with the fibrous joints. So at fibrous joints, adjacent bones are directly connected to each other by fibrous connective tissue. In these joints, there are no joint cavities that are present, and the fibers that make up the joint are composed of collagen. The gap between the bones could be very narrow and could contain very short fibers, or the gap could be much wider and would contain much longer fibers. In fibrous joints with a very narrow gap, these are classified as synarthroses because they permit no movement at the joint. Meanwhile, the fibrous joints with much wider, much broader gaps between the bones are classified as amphiarthroses because they permit some movement at that particular joint. There are three types of fibrous joints: the sutures, the syndesmoses, and the gomphoses. Although these joints have different names, they all have the same basic structure that we just examined on the previous slide. The only difference between them is their locations in the body. So sutures are the narrow fibrous joints that are found between most of the skull bones. These are strong joints that tightly bind the skull bones together for the function of protecting the brain and creating a supportive skull. The fibers tend to be very short and therefore permit no movement at the joint, and therefore these are classified as synarthroses. At syndesmosis joints, the bones are more widely separated, but generally they're held together by a narrow band of collagen fibers called a ligament, or sometimes that ligament is much broader, and it's called an interosseous membrane, and we'll see an example of an interosseous membrane in the next slide. Because these joints do allow for some limited movement to occur between the adjacent bones, the syndesmoses are functionally classified as amphiarthroses. A torn syndesmosis is generally referred to as a sprain, so that's where we tear a ligament or an interosseous membrane. So in the forearm, the gap between the radius and the ulna bones is filled with an interosseous membrane that helps to link the radius and the ulna together. And this interosseous membrane is basically a very broad ligament. The membrane helps keep the bones aligned, but it does not keep them immobilized because the joint still allows for the radius to rotate over the ulna during rotation of the forearm. The membrane also helps to provide a surface for muscle attachment. Last, we have a gomphosis, which is a specialized fibrous joint that anchors the root of a tooth into its bony socket on either the upper or the lower jaw of the skull. Small ligaments, called periodontal ligaments, function to secure the tooth to the jawbone. The short length of the fibers in the gomphosis permits no movement of the tooth in the socket, and so for that reason these joints are functionally classified as a synarthrosis, much in the same way that the sutures are. So continuing with the structural classification of joints, we'll examine the cartilaginous joints. So as their name implies, this is a type of joint in which the adjacent bones are united by hyaline cartilage or they're united by fibrocartilage. These joints also lack a joint cavity. So the term that is used for a hyaline cartilage joint is called a synchondrosis. Meanwhile, a symphysis is a cartilage joint in which fibrocartilage is going to unite the two adjacent bones. So here are a few examples of a synchondrosis. Hyaline cartilage is a tough and rigid cartilage, which makes it ideal for non-movable joints. So these are generally functionally classified as synarthroses. Hyaline cartilage is very similar to bone in that it can resist compressive forces, but not tensile or pulling forces. And so you'll notice that it's found in places where generally compressive forces will dominate. The epiphyseal plate between the epiphysis and the diaphysis of long bones represents a temporary synchondrosis because the epiphyseal plate is the region in which the long bone growth occurs. Generally by our early 20s, the epiphyseal plate will be completely replaced by bone tissue, and the long bone will stop growing in length. Permanent synchondrosis joints exist in the thoracic cage, so the joint between the sternum and adjacent ribs, which are referred to as the sternocostal joints. And here a bar of hyaline cartilage actually connects the ribs to the sternum, so that is for the ribs that will actually form a connection with the sternum. When we examine the skeleton in a little bit more detail, we saw that the ribs don't all make a connection to the sternum. There were a few ribs that did not connect to the sternum at all. So recall that cartilaginous joints where the bones are united by fibrocartilage are called symphyses. And fibrocartilage contains many bundles of collagen fibers, which makes it able to resist both tension, so that is pulling forces, as well as the compressive forces that cartilage is very well suited for handling. So perhaps unsurprisingly, we see that fibrocartilage is found in places where both tension and compression forces could be present. It does allow for some movement between the bones that it joins, and so thus symphyses are functionally classified as amphiarthroses. The bulk of the intervertebral discs, which is in the image on the left here, that is, these discs between the vertebrae are composed of fibrocartilage. This gives the vertebral column some flexibility. The very thick intervertebral discs also provide a protective cushion between the vertebrae for high-impact activities, such as jumping or running, or when we are carrying heavy objects. So there is a small amount of hyaline cartilage on the ends of the two vertebrae, that is, between the intervertebral disc, but the hyaline cartilage only serves to protect the surface of the bone tissue, rather than actually physically uniting the bones together. Another symphysis is located between the two pubic bones at the anterior aspect of the pelvic girdle. So here, the fibrocartilage joint is called the pubic symphysis, and it does permit some very limited movement at the front of the hip bones. The function of this joint is to provide stability for these bones, and also helps to keep the bones aligned, just like with other joints. Stability is particularly important for the hips, just because they are functioning to transmit the weight of our body to our lower limbs. And in addition, the limited movement of this joint does allow for the pelvic girdle to expand during childbirth in females.